There are three radii. One is the atomic radii. One is the atomic radii. Like this is the atomic radii. And if you notice 0.15 to 0. So as you go in the period, it is going on decreasing. It is going on decreasing. Now, why this happens? Look, you will have to, whenever you're talking of atomic radii in a period, you'll have to be noticing that the charge, the protons and the neutrons are going, electrons are going on increasing as you go to the right. So the shielding is constant because they're added to the same shell number. So what will happen is because the charge is increasing, the attraction will go on increasing. And when the attraction goes on increasing, the cloud will be held closer. The cloud, electron cloud will have a closer. So the radii will decrease. The radius will decrease. If you go down a group, this happens in a period. If you go down, the charge, though is increasing, but the shielding is more because now more shells are being added, and the shell number is so going down. The shell atomic radius will go on increasing. This is as far as the atomic radius. But when they talk of ionic radius, it's slightly different. There could be two radii, one cation radii and one the anion. Now, if you notice here, this is the cation radii is reduced. This is 0.60 and it's going on reducing. Is 0.20. See, boron is 0.080 here, and here it is 0.02. It's much less. Why? And you see the anion, these are anions. So these are the cations, these are the cations, these are the cations, and these are the anions. The anion has increased. Nitride ion 0.171. See, nitride 0.074. So two things happen. One, this decreases, cation radius decreases. Cation radius is less than atomic radius, and anion radius is more than atomic radius. Why this happens is because you see the when cation is formed, a shell is lost. So there, one thing, the shell is lost. The one reason. The second reason is there are more protons and less electrons, so they are held greater. So it is attracted closely. Anion, the shell is not lost. There are more electrons added because some electrons have come in. So there are less protons, so it's not held properly. So it expands, the cloud expands. So the top, an ionic radius is greater than. So you have to think in terms of three: an ionic radius, cationic radius is and an ionic radius and atomic radius. All the comparison. Notice in ionization, we have to think of distance of shell. This comes from these atomic radii. Shielding, we also think of shielding here, but here we also think of shielding of subshells, SPDF, and the sub shielding of S is greater than P and D, and also this. We think that in terms of charge. We are also thinking in terms of charge in atomic, but we don't think of spin pair in atomic radii. We don't think of half filled, close filled, and so there is these factors are slightly different. The factors affecting ionization are different, slightly different, and of course they are related. So it is like this. There is this nucleus. It is um, attracting. These blue lines are the attraction between the electron and the nucleus, and there is also repulsion between electrons. Uh, there is, though repulsion is shown between these, there could be also repulsion here, but only repulsion between outer is shown here. But if you remove an electron, like in the case of a cation, there is less repulsion because there were 1, 2, 3, 4, 5, 6, 7, 8, and now there are 1, 2, 3, 4, 5, 6, 7. So there is less repulsion. So they come closer. When electron is removed from atom, the remaining electrons are drawn closer to the nucleus due to the reduced repulsion. Because now the repulsion is less, so they come closer. That means this distance is reduced. This distance was more. The cloud has come closer. So this is what happens. Why is the cation radius less? And the opposite happens when in anionic radius it increases.